We have found this result for the partition function in 0 dimensions with n fields, and we know that the action is quadratic in the fields. So we in particular wrote S of phi equal to 1/2 m phi phi like this, where m phi phi can be interpreted as MAB phi A phi B, and this matrix M or MAB, if you think of it in terms of indices, in index notation, well, this is a positive definite matrix, and it is symmetric. And this was the action that we considered in the previous lecture. Now we are going to add another term to the action of the kind J dot product phi, and in particular we will interpret this dot product as JA phi A, so it's a summation over A, or if you want, which is the same, JA phi A written with the opposite convention for upper and lower indices. So we can either put the upper index here or we can either put the upper index here. It doesn't really matter. Anyway, how do we take into account this J, which represents a source? This is also known as a source for the partition function. Well, we can rewrite this this action here in terms of another field. In particular, we can define phi tilde to be phi plus m inverse j dot here. Now let me tell you what this represents. This basically means, in index notation, phi a equal to, phi a tilde equal to phi a, plus we have the inverse of m, and then we have two indices for m inverse, which are a and b, and then here we have jb. So we have to sum over j, we have to sum over b. So this is how you should interpret this notation here. Here we put a dot simply because we only have to sum over one of the two indices of the inverse matrix, which is symmetric, remember. So we can either put b here, or we can also put b here, and a here. Doesn't matter because this matrix is symmetric, just like M, right? So if we use this definition and we put this definition there, we can rewrite the action. So the action can be written as 1/2 m, and then let me use index notation. So we have MAB phi A phi B plus, and then we have J, so we can use either JA or JB, doesn't matter. So we have phi A JA written like this. And now we can use this definition here for phi tilde, so we can replace, instead of phi A, we can put phi A tilde minus this. So this is equal to 1/2 MAB, then we have phi tilde A minus M inverse AB JB. And now we have to pay a little bit of attention because here we have B. So here we are summing over an index, but this should be a dummy index, so we should call it a different manner. So we can put C here, for example. And we have to pay attention to that. So instead of phi B, we can put phi tilde B minus M inverse. And then we have B, D, J, D, like this. And then, of course, we have phi tilde A minus, here we can also put M inverse. We can use B in this case because there is no ambiguity. This is not multiplied by anything else. So we have M inverse AB, JB, and then we have JA, like this. So we can work out the details. We have this multiplied by this and this, which is 1/2 MAB phi tilde A phi tilde B. And then we have a bunch of other terms. So in particular, we have this multiplied by this, and then we have this. So we have a minus 1/2 MAB phi tilde A M inverse B D J D, like this. And now you can see that this MAB with this M inverse BD will give you a Kronecker delta. A Kronecker delta with a lower a and an upper d. And this will simplify the expressions. But anyway, let's move on. So we have considered this multiplied by this multiplied by this, and then we have this multiplied by this. And of course, also this. We also have a minus 1/2 MAB. Then we have M inverse AC, JC, and then we multiply by phi tilde B. And finally, so we put a plus here, and then we have this multiplied by this multiplied by this. So we get an overall plus 1/2 MAB M inverse AC JC M inverse BD JD. And you can see overall that, for example, here we have MAB M inverse AC. Remember that these matrices are symmetric, so we can put B, for example, here, and then we can put A here, or vice versa here. We can swap the order between these two. Therefore, here we will get a delta, a Kronecker delta BC. Simple as that. And similarly here we can simplify this expression because MAB M inverse AC will give you a Kronecker delta of the kind CB, like this. And finally we have to consider these terms. So we have plus phi tilde AJA minus M inverse ABJB. Now when we consider this term, so for example, let's consider this term here without the 1/2. So we can rewrite that, of course, as phi tilde A JA. So we have to sum like this. And for example, this one here will be JB phi tilde B. So it's exactly equal to that. So we have minus 1/2, which will give me, it will give us minus 1 times either these or these. It's not important because these are just dummy indices. And then you can see that we have plus the same thing here. So this will cancel, so this term will cancel this one, and we also cancel this one. Simple as that, right? And then what else do we have? We have to consider this, and let me rewrite it. So this, how can we rewrite this? We have delta CB, which multiplies JC, so it will become JB. Then we have M inverse BD JD, and then we get another quantity here. So we are left with the following. We are left with 1/2 MAB phi tilde A phi tilde B plus 1/2, and then here we have JB M inverse BD JD. And now I have realized that here I am missing one term. So here I should also put JA, because if you check where we started, so this is multiplied by JA there. So we also have to subtract this, and therefore from this 1/2 here we have to subtract 1, because you can see that this has the same form as this, and therefore at the end of the day here I will get a factor of, so I will have minus 1/2 instead of plus 1/2. So we can also write this as 1/2 m phi tilde, and then we can write minus 1/2, and I have m inverse jj like this. And therefore the partition function, which contains j, can be written as integral over, in general we have dn phi, and then we have the exponential of minus 1 over h bar 1/2 m phi plus j dot phi, like this. And now using the result that we got in here, you can see that, I mean, the Gaussian integral can be written in a simpler form, because we get rid of this linear term in phi by, I mean, thanks to the substitution that we used, and therefore we can rewrite this as, notice that when we make the substitution, which is a linear substitution, we will have dn phi equal to dn phi tilde. So the differential will become, will transform in a simple manner. In this form we have integral dn phi tilde exponential of minus, so this is not a complex exponential, you can see, but because we have weak rotated the time coordinate, so we are considering a Euclidean space, minus 1 over h bar, and then we have 1/2 here, and then m phi tilde like this. And outside of the integral, so this is just the integral, but outside of the integral we have the exponential of 1 over 2h bar m inverse jj. We know how to evaluate this expression, because this is simply z0. It's exactly z0, because now we have, the only difference is that the variables are called phi tilde, but the form of the integral is exactly the same, and therefore also the result will be the same. So all in all, now let me zoom in a little bit. We have z of j, we can write it as the exponential of 1 over 2h bar m inverse jj, and then we have z0. So this is the result that we have with a source called j, and we will move on from here next time.